This last video is about using multiplication to help us solve the division facts, starting with basic facts, but I want to extend it a little bit at the end to show you the future impact as well. So for our students, when they're asked a division fact like 48 divided by 8, they're going to think to themselves, do I know it? Does the number 6 pop into my mind? If they don't know it right away, we can ask them to think multiplication. 8 times something is 48. Do you know what that is? And again, they're going to think and try to retrieve from memory, what is that number, right? Now, if they don't know the number, we want to make sure we're helping them move past the counting one by one. So rather than putting out 48 dots and then circling every 8, or rather than skip counting by 8s or even repeatedly subtract 8s, right? This is in the realm of the basic facts now. We want to help them develop this mastery of this thinking that can help them get them more efficiently to their quotients. We want to be able to imagine that rectangle, that every multiplication problem can result in a rectangle. So with division, we're trying to find the largest rectangle we can make. Now, you might have some leftover amount sometimes when we're dividing other dividends other than within the basic facts, but still the idea is set that I can think about, well, how many groups of 8 do I know for sure? Because I might not know what 48 divided by 8 is, but I can figure it out, right? I can use what I know to help determine what I don't yet know. And I can be visualizing and doing it first concretely and then pictorially to help me visualize it and maybe even do it as a mental math strategy as well. So concretely, what we can be doing is we can be building arrays with the any physical objects that you want. Here within the Braining Camp app, they have an array tool. So what I can think about is, well, 48 divided by 8. Do I know any facts of 8 for sure? And if I know for sure that 8 times 3 is 24, so an 8 by 3 I know has an area of 24, well, how many more do I have to deal with? Well, maybe they might recognize that it's another 24 to get to that 48, right? And so if I know that, well, then I can be thinking about two, partial quotients within that 48. I can be decomposing the 48 into chunks that I'm more familiar with. So I can decompose my 48 into 24 and 24, and then I'm dividing each of them by this 8. So I can be thinking multiplicatively. 8 by 3 gives me an area of 24. I have another 24 to go to make a total of 48. So what is that total distance? What's the total number of groups that help me get to that total amount? Well, it turns out to be 6. So I know that that total grouping is 6. Now, I just want to show it to you another way, because what if I didn't know that 8 times 3 was 24? Maybe I know that 8 times 5 is 40. I can use that as well. So it all comes down to, what do the students know? What do they know for sure, so they can use what they know to help them derive what they don't yet know. So I can think about an 8 by 5. I know 8 times 5 is 40. And that gets me really close to that 48. So I know I already have 5 groups of 8 in the 48. It is 40. How much more do I have to go? Well, I have one more 8 to go. So I can be bringing out again another, I'll just do a 1 by 8. So I have an array 1 by 8. I know this area inside here is the 8. And so what is that total distance, the total number of groups that I had? Well, obviously it is still that 6. But you can see how the pathway is open for students to use various facts to get there. They're building their understanding that we can be thinking multiplication and use the facts that you do know, that you've mastered, so you can retrieve them from memory to help us derive the ones we don't yet know. And that will become a mental math strategy for them as well, even as they're dealing with larger numbers and way down the road, decimals, fractions, polynomials. And so if I were to think about this pictorially, I can draw the area model myself. So I can have my 8. I know that's going to be my vertical distance. Now, I don't yet know a total amount yet, so I'm not going to draw my ending line there yet. But I do know for sure that 8 times 5 is 40. So I can be knocking off part of that. And I do know that 40 is pretty close to 48. So I know I'm almost done my rectangle. We do want to have the students draw the area model like this, relatively proportional to the quantities that they're dealing with. So 40 already I'm dealing with. I have 8 more to go, which is just one more group of 8. And so again, I'll be showing you that area model here, but I've drawn it now as a picture. I'm recording my partial products. And even abstractly, I could be recording it as these partial products. Well, I know 8 times 5 is 40. And I know that 8 times 1 is 8, which means that in 8 by 6, those two groupings together must be that total of 48. So I've thought multiplication to help me solve the division. Here's another model of Cuisenaire rods, being able to model this, thinking about this area model. So let's think about 48 divided by 6. Do I know 48 divided by 6? No. Do I know 6 times what is 48? No. So what is that thinking I want to have happen with the students? I don't want them reverting to skip counting by 6s. I want them to think, what math fact of 6 do I know for sure? A lot of students know 6 times 5, right? So if I bring out 5 of the 6 rods, so they're seeing them exist as a group. So I have 5 of these rods. So if I'm even label this for us as 6, and coming across here is 5, and I know that that area is 30. It's a math fact that I can retrieve from memory. I know that that is 30. Well, how many more do I have to go in the 48? So I can think, well, 10 more to 40, 8 more to 48. So it must be 18. Do I know how many 6s are in 18? And maybe I do. So I can be bringing out, let's say, 3 more. So I can show you that other partial quotient, that 3 6s I know is 18. So this total of 3 groups of 6 is 18. And so I know that the area inside this rectangle would be 30 plus the 18 for the 48. It measures 6 by a total of 8, right? We can be joining together the 5 groups and the 3 groups to make a complete area. So I can even slide these over here. We've made a 6 by 8 rectangle with a total area inside of 48, in which case then I know that this must be 8. As we move over to the pictorial way of doing this thinking, well, I know I can make an area model. I can come down 6. So I could be drawing an open array here. Maybe I know for sure that 6 times 4 is 24. So I can be recording that partial quotient there. Now, how many more do I have to think about? Well, if I'm at 24, I'm going to go up to 48. I might recognize at this point that it's 24 more, that in fact, I have to just go another 6 by 4 rectangle to make that total of 48. So our distance is 6 by 8. Again, getting to my 8. But you can notice I'm not limited to any one way of thinking this through. This is all based on do I know for sure. And this is that multiplicative reasoning of using these partial quotients to make up my total. As I then get to the abstract, where I can be recording that 48 divided by 6 equals 8. It can be even recording that, thinking that 6 times something equals 48. And what I can figure out of what that must be. So really powerful progression as we think about this area model to help with our division facts about thinking multiplication. But again, comfort zone of the students. What do you know? And how can you use what you know to figure out what you don't yet know? Now, I do want to show you a little bit of a future impact with this work of thinking multiplication to solve division. So it does start with the basic facts, but we can extend it now to other divisors, even 2-digit divisors, when we think about using the multiplication work that we do know to help us solve the things we don't yet know. So their disposition of the students will be increased. So if I have 156 divided by 12, I'm going to imagine a rectangle. 12 by something gives an area of 156. Now I'm within this Braining Camp app under the factors mat. So you can see here that I am just dragging along here total distance of 12. So on the bottom here under workspace, you'll see factors is the mat I'm working in. So it allows you to build these for larger numbers really easily and efficiently. So I'm going to have this distance of 12 and I want an area of 156. So I might ask the student, what multiples of 12 do you know for sure? Now, really helpful is having our place value work come into place here as well. So do you know how many 10 12s is? What's 12 times 10? Like how far can I get to get close to that 156? Now, if I know that 10 times 12 is 120, I can model that here. So I can be always rotating these. I'm going to be building that here. I'll just copy it again. So now if you imagine, I have this rectangle here that measures 12 and it goes across 10. So I already know that I have a distance of 10 and an area of 120. So right here, I can be taking care of 120 out of my 156. I could even take out one of my 10 rods and just show that as a distance up here. So outside of here are just the markers for the distance of the rectangular array here. But so I know I already have at least 10 as my answer, my quotient, right? I know at least 10 groups of 12 are in 156. So how many more do I have to go? How many more do I have to deal with? Well, now I could subtract 156 minus 120 and I would get 36. So I have 36 more to go. Now students might know that that is 312. And so I can be building it by bringing over a 10 rod here and then 2 more of these cubes. So I know I have that distance of 12. Again, this is one more group. So I'll add that marker up here, one more group, and then a second group of 12. And in fact, I can copy this 12 right there. And I can copy it a third time. So I want to mark that with one more cube here so that I have this rectangle. So I've added on a 3 by 12, which maybe I know already is that 36, where I could have just been adding 12s. But if I know that 3 groups of 12 is that 36, well, here I have my area of 156. The vertical distance is 12 and my horizontal distance is 13. So I know that my quotient must be 13. So again, I've just been breaking it apart into partial quotients on my way to figure out what the quotient is. And the beauty of exploring the basic division facts in this way that introduces this area model, this rectangular model in their mind, is they can be visualizing it as they're using various math tools, so they can then visualize it in their brains. It becomes a mental math strategy. So you can think about, if I have 8,016 divided by a 4, 4 times something must be 8,016. And do I have enough to make an area of a 4 by 1,000 rectangle? And I do. In fact, I have enough for 4 by 2,000. So I can be even making a pictorial representation here and marking that I have a 4 by 2,000. Well, that gives me an area of 8,000, right? So I'm already taking care of 8,000 of this amount. And how much do I have left to deal with? 16. So I can be even representing here another rectangle here. Of course, it's not going to be truly proportional at all, but I can be putting, this another 4 times 4 is 16. So I have my 8,000 plus my 16 more, giving me a total distance of 2,004. So I know that that is my quotient. But again, the power of this, that the students are thinking and reasoning their way through this, and it's not the same path as what happens to when you do a traditional US algorithm of bringing down numbers. The students get very unreasonable quotients and they don't realize that they're not reasonable. They were just locked in those procedures of single digit facts as they were working their way through. So this sets up that model of that foundational understanding of this area model, which will also extend to fractions and decimals and polynomials way down the road.